Okay guys, sorry that I ended that last video abruptly, but this is part 2 of the second video and it should be much shorter for this video number 3. I have the unit circle here. I'm going to have you pause the video in a moment to answer these 6 questions, and then when you're ready you'll resume the video so that way you can see the answers. I had the last tip being sine relates to y, cosine relates to x, and tangent is y over x. What that means, as a first example, is that if I go to sine of 5 pi over 6, well, 5 pi over 6 is this angle right here, and if I look at the y value, I know that this value is 1/2, which is what I would get on the calculator. Your job is to calculate the other 5. Please pause the video now, resume when you're ready to go. Okay, let's see if we got them right. Cosine of 5 pi over 4 should be negative root 2 over 2. I have here that cosine is in the 5 pi over 4 is in the third quadrant, and that 5 pi over 4 relates to the x-coordinate of pi over 4, which is really negative root 2 over 2. So all these little portions that I have here are me using my reference angles. Because again, I learned in the past that students have a hard time remembering where these angles actually are, and then having to then remember the coordinates related to those angles. But if you can remember where the angles are, then the signs will take care of themselves. For instance, the cotangent of 5 pi over 3. Well, 5 pi over 3 is in the fourth quadrant. I also know that cotangent is 1 over tangent. Tangent of pi over 3 is root 3. And since I'm in the fourth quadrant, I know I'm going to have a negative value for cotangent. Therefore, 1 over negative root 3 is your answer. If you're wondering why fourth quadrant is going to be negative for cotangent, I just want to quickly remind you, ASTC, cosine is positive, which means all the other values here for the trig functions are negative. For the next one, negative 7 pi over 4 might have been tricky, and actually the last 3 might have been tricky, and here's why, is because we have a negative value. Negative means we're going clockwise. So instead of going 7 pi over 4 here, I went negative 7 pi over 4, which really means, let me get rid of this, which really means that I did 2 pi minus 7 pi over 4. That happens to be pi over 4. So this value that I'm actually looking at is pi over 4. The sine of pi over 4 is 1 over root 2. The cosecant of pi over 4 then is root 2. It's positive because we have a first quadrant value. Secant of negative pi over 3. Again, when I go clockwise, it might be easier to just look at this as 2 pi minus pi over 3, which is the same thing as 5 pi over 3. Now, since we're in the fourth quadrant, we know our x-coordinate is positive. And since I am looking at secant, I'm going to have to look at the cosine of pi over 3, or 5 pi over 3. The cosine of pi over 3 is 1/2. And if I want the reciprocal, I get 2. Finally, tangent of negative 5 pi over 6. If I go backwards, negative 5 pi over 6, I'm really at 7 pi over 6. 7 pi over 6 relates to pi over 6. And the tangent of pi over 6 is 1 over root 3, or root 3 over 3. And this value is positive because, again, ASTC in the third quadrant, tan is positive. Tangents are always tricky, tangents and cotangents. The tangent of pi over 3 is the same thing as sine pi over 3 and divided by cosine of pi over 3, which is root 3 over 2 divided by 1/2, which is root 3. But that's just a lot of work. So one thing that I tell my students is the tangent of pi over 3 is root 3, and if you can just remember that, knowing that the 3 belongs in the root, the tangent of pi over 6 is the reciprocal. So 1 over root 3 will be in the denominator. Hopefully this little trick, knowing what tan of pi over 3 is equal to root 3, hopefully knowing that will save you some time when you're doing this kind of problem and that kind of problem, C and F. Okay, let's do coterminal angles. Coterminal angles are when you've gone a full revolution around and your terminal side is the same as one for a smaller rotation. Sine 25 pi over 6 is exactly we'll need a coterminal angle. And since we're talking about 6, because 6 is in the denominator, since we're talking about the denominator 6, let's look and see how many 6 does it take for a full revolution. That should be 12 pi over 6. And if I go another full revolution, then I would get 24 pi over 6. Adding another 12 pi over 6. So if I want to get to 25 pi over 6, I just have to go an extra 5 pi over 6. Pi over 6. So sine of 25 pi over 6 will be equal to the sine of pi over 6. The coterminal angle is pi over 6, and the reference angle and the coterminal angle will be the same this time. So your answer, since I'm going to look at the y value, because sine is y, because I'm going to look at the y value for pi over 6, I'm going to get a value of 1/2. Negative 58 pi over 3. Well, same thing. Let's go and take a look at how many pi over 3s there are in a full revolution. And that looks like it's going to be 6 pi over 3 to get the 2 pi. Now, I'm going to be doing this a long time to get to 58 pi over 3. And let's also notice that we do have a negative value, so we are looking at negative 6 pi over 3. So one way we could cut the work in half here is do 58 divided by 6. And if we do the math on that, we get 54 with a remainder of 4. So in order to see how many total revolutions, it's going to take 9 revolutions and an extra negative 4 pi over 6, which is a negative 2 pi over 3. So I'm really going around negative 2 pi over 3, which is right here. So the coterminal angle is going to be 5 pi over 3. 5 pi over 3, of course, not of course. 5 pi over 3, though, does relate to pi over 3. I'm looking at the cosine of 5 pi over 3, which means I'm looking at the x value here. And the x value for the cosine of pi over 3, the x value at pi over 3 is going to be 1/2. Tough problem. Hopefully it didn't give you too much of a fill out the unit circle completely on your own without looking. See if you can do it, see how long it takes. Here's a website for you that's going to help you with a few more here's a website that's going to help you with the unit circle a little bit more. And this is going to be the end of video number 3, parts 1 and 2.